Click for IB Biology. We are continuing our study of the cell membrane, and we're going to look at the movement of water across the membrane. Of course, students will be familiar with the idea of osmosis, which is the study of the movement of water across the membrane. And here we're looking at the movement of water at the molecular level and the mechanism by which it actually moves through that membrane. There's a blank PDF of this presentation linked down in the description there. You'll find a quiz with 10 questions along with the answers that you can use to evaluate your own learning. Water moves through the cell membrane. It is possible by two mechanisms. The first one is almost a form of simple diffusion, and this almost sounds contrary to the rule that we've developed. Individual water molecules are small enough that they can move through the cell membrane unimpeded by the hydrophobic layers of the fatty acid tails. That sounds almost like a contradiction. Since they're hydrophobic, surely they should repel water. The hydrophobic repulsion of the fatty acid tails relates to large amounts of water, not individual molecules. And of course, a water molecule is considerably smaller than an oxygen molecule. So individual water molecules can move through the membrane directly, but our main concern and the major movement of water actually occurs through a protein structure called an aquaporin. So aqua as in water and porin as in pore. And this aquaporin structure is a protein that is embedded in the cell membrane and which has a core down through its center, which allows the free movement of molecules. And of course, that core necessarily needs to be hydrophilic in nature so that it does not repel the water molecules. So this black structure here, which I've drawn there, now outlining, is a solid protein. It's actually a transmembrane protein, which we'll develop that idea in the next couple of videos. And down through the center of this protein, there's a hydrophilic channel, which means the water molecules do not come into contact with the fatty acid tails, and so they're not repelled. Now the water then will move in the direction from what is called the lower solute potential to the higher solute potential. This is our first definition of osmosis as we move into the syllabus. So water moves from the lower solute potential to the higher solute potential. Let's explain this a little bit. If you think of a solution has is a combination of solute dissolved in solvent. Now the solvent is of course water. If we have low solute, that means there's not much solute. Another word for this would be dilute. Higher solute potential would mean there's lots of solute, and so we could relatively call this concentrated. So you'll be familiar with that definition, that water moving from the dilute solution to the concentrated solution. Now we upgrade this to the definition of water moving through the cell membrane from the lower solute potential to the higher solute potential through aquaporins, which allow it to traverse the membrane and avoid the repulsion of the fatty acid chains of the lipids. The link to the next video is appearing in front of you, along with the channel subscription button, which you could always subscribe with, and the playlist to all the other videos in this section on cell membrane.